Welcome to the unit circle. Today's objectives are to convert angle measures between degrees and radians and find the values of trigonometric functions on the unit circle. Before we discuss the unit circle, we're going to talk about radians. Now, radians are a unit of angle measure based on arc length. We're used to basing angles around degrees, but today we're going to learn how to measure them with radians. So a radian is a unit of angle measure it's based on arc length. So where do radians come from? Well, they come from the unit circle. So if we have a circle here, with this blue line as a radius, basically imagine that radius is taken and that exact radius is stretched along the side of the circle. That right here, that's called a radian. So the next question is, how many radians are in a circle? So let's look at radians per circle. Well, if we go back to this original circle that we drew, let's imagine that that's 1 radian. Let's imagine that that's 2 radians. And then 3 radians would be about here, and then we have a little bit left over. Now, if you're familiar with the symbol, the irrational number pi, you know pi is about 3.1415, and then it keeps going and going and going. So per a half of circle, there's 1 pi. So in a full circle, which we're used to seeing as 360 degrees, that's going to be 2 pi radians. So in a half circle, or a semicircle, pi radians. In a full circle is 2 pi radians. So how do we convert from degrees to radians and backwards? Well, if we're going from degrees to radians, we take the number of degrees and multiply them by pi radians divided by 180. And if we're going from radians to degrees, we multiply the number of radians by 180 over pi radians. And this is all based on the fact that pi radians equals half a circle, or 180 degrees. Now let's practice converting from radians to degrees or from degrees to radians. So for our first example, we're going to convert negative 36 degrees to radians. Now, since we're going from degrees to radians, we're going to multiply this by pi radians over 180 degrees. Now we multiply these together. There's degrees here and there's degrees here, so those cancel out. And what we're left with is negative 36 pi radians over 180. When we simplify that fraction, we end up with a 1 on top, so we have negative 1 over 5. And the unit of measure for this, these are radians. Okay, let's try another one. So we're going to convert 4 pi radians to degrees. So since we want to get rid of the radians, we're going to put those at the bottom. And multiply by 180 over pi radians. Now the radians cancel out, the pi's cancel out, and what we have is 4 times 180, which is equal to 720 degrees. And that's how we convert from radians to degrees or from degrees to radians. Okay, let's discuss the unit circle. Now the unit circle is used for many things in trigonometry, but all we want to use it for today is to look at how degrees convert to radians and how radians convert to degrees. So the unit circle is a circle with a radius of 1 unit. So let's draw an example of this right here. So we draw the unit circle on an x and y coordinate plane. And the radius is about 1 unit. Now, we want to look at this, we want to determine the degrees and radians at different points in the circle. So for example, we already know that this is 0 degrees, this is 90 degrees, 180, and 270. Those are the degrees around the unit circle. But we just talked about radians, so let's determine what those are. So out here, same deal, we would have 0 radians, or 0 pi. Now we know a half circle is pi radians. In between 0 and 1 is 1/2. So here we have pi over 2 radians. Now if I start here at 0, a half, 2 halves, or 1, right here we have 3 pi over 2. Or you could think of it as 3 halves. Now I can find the conversion between degrees and radians at any point of the circle based on what I want to find. So let's say I wanted to examine this point here, which is 45 degrees. Well, I already know how to convert from degrees to radians. So if I had 45 degrees and I want to convert that to radians, I know I have to do 180 degrees over pi radians, which ends up being pi over 4. So at 45 degrees, I have pi over 4. Now in future examples of the unit circle, I'll be giving you all the measurements, but this is where all of those measurements come from. So the most important thing you want to know is that the circle has a radius of 1 unit. So at any point from here to the points outside, it's 1 unit. And that'll be important to know going forward in trig. So now that we're familiar with the unit circle, we're going to use it and reference angles to find the exact value of sine, cosine, and tangent of the angle 225. So the first thing we want to do here is we want to draw the angle. So we make our XY plane, and we draw the angle 225. So 225 starts here, go to 90, 180, and we go 45 more degrees here, and now we're at 225. Okay, the second thing we want to do is find the reference angle. Now remember, the reference angle is the quickest way to get back to the x-axis. So I want to go up this way, and to get back to the x-axis, I need 45 more degrees. So this right here is a 45-degree angle. Now, after I've drawn the angle and found the reference angle, what I want to do is notice that I've basically drawn a right triangle here. So my next step that I want to do is redraw that right triangle. But I want to draw it the same way that it is on this x and y plane. So I see that I have this side here, this other side here, and this point here. So now I have this right triangle where this is a 90-degree angle. I've already decided this is a 45, and we know if this is a 90 and this is a 45, the last angle has to be 45 as well. So what we have here is a 45, 45, 90 triangle. Now, we know the ratio of the sides of a 45, 45, 90 triangle. We know that usually this side's 1, this side's 1 as well, and this side is the square root of 2. But we have to think about these compared to the x and y plane. Technically, if we were talking about this side right here, it wouldn't be positive 1, it would be negative 1. So you want to make that a negative 1. Also, if we were talking about going down this way, it wouldn't be a positive 1, it would be a negative 1 as well. Now, whenever we draw these radii, these will always stay positive. So now, after we redraw the triangle with the ratio of the sides, the last thing we want to do is we want to find the trig values based on the reference angle. So the first we want to find is sine. So we're going to find sine of that angle. Well, we know sine is opposite over hypotenuse. So we have negative 1 over the square root of 2. Now we convert that to be negative square root of 2 over 2. And that's how we use the reference angles to find the exact value of sine, cosine, and or tangent of an angle. So we draw the angle, we find the reference angle, we redraw the triangle, and then we find the trig values based on the reference angle. Now I only did sine here, but if you want to find cosine and tangent, it'd be the same thing. You'd base cosine off of the reference angle and tangent off of the reference angle as well. Okay, let's try one more example of using the reference angle and the unit circle to find the value of sine, cosine, and tangent of an angle. So in the previous example, we did one that was in degrees. Now let's try converting one in radians. So let's say I wanted to find the cosine of 11 pi over 6. Okay, so my first step's going to be a little different. I want to convert radians to degrees. So I'm going to have 11 pi over 6. I'm going to multiply it by 180 over pi. And when I do that, the pi's are going to cancel out. And I'm going to be left with 330 degrees. Then, after I convert from radians to degrees, the steps are pretty similar to the last example. We want to draw the angle first on our coordinate plane. So, here's our coordinate plane. We draw 330, and we start from here. So it's 90, 180, 270, and 330. After we draw our angle, we want to find our reference angle. So we go back to our angle here. We know that this is 330. So the quickest way to get back to the x-axis is to travel 30 more degrees. So our reference angle is 30 degrees. So we have our triangle now we can draw. And it's going to be a 30, 60, 90 triangle. So our reference angle here was 30. This is our right angle over here. This one's 60. And after we draw the triangle, we want to draw the triangle with the sides, based off of the 30, 60, 90 triangle. So we know opposite of 30 is 1. The hypotenuse is 2 times the short leg. And opposite of 60 is square root of 3. Now I want to make sure that we get all the signs correctly. Technically this side would be positive, but since this is going down here, we have to make this side negative. So that 1 there's negative. So now we have to find cosine. So now that we have this, we can find the cosine based on the reference angle. So the reference angle is 30. We know that cosine is adjacent over hypotenuse. So therefore, the cosine of 11 pi over 6 equals the square root of 3 over 2. Now if we want to find the length of an arc around a certain aspect of the circle, we have to use the formula S equals R times the central angle. Now R is the radius, S is the arc length, and theta stands for central angle. So if we know any of those three things, we can find the measure of an arc around a circle. So for example, if we knew that the radius was 10 feet And we know at this angle here, theta is pi over 4 radians. Since this central angle is always measured in radians, we can figure out the length of S. So S would just be 10 times pi divided by 4, or 5 pi over 2. And that 5 pi over 2 is measured in radians. Arc length is measured in radians. And that'll be the end of our video for today. Thank you and take care.